So in this problem they're asking us to find the maximum area of a rectangle whose base is on the x-axis and whose vertex, top point, touches the curve y equals 8 minus x squared. So as I drew it, we should draw it again just to be clear. It says that the graph is 8 minus x squared. We know that if it's negative x squared, it doesn't go up but it goes down. So as it goes down like this, we know also that they're asking us the maximum area with the top vertex points touching the line, the curved line, with the concave down. Okay? So we need to find a relationship that exists between the area and this graph. We know, or we could say, that x, this could be x and the height could be y. So the point is x comma y. We also, okay, so if we say that x, this is x and this is x, so we have 2x as the base and as the height y. So area of the rectangle is base times height, right? And if we actually plug it in, we know that it is 2x times y. And this problem we get y. So simply enough, we just plug in y into this equation, which would be 2x times 8 minus x squared, and we just simplify. So 2x times 8, 16x minus 2x cubed. That's the area, and this is what we want to maximize, so we take the derivative of this. So if we take the derivative of the area, we get 16 minus, using the chain rule, we lower this and multiply by this, so negative 2 times 3 gives us 6 x squared times the inside of this, the derivative of the inside of this, which is 1, and so basically we have to set it equal to 0. So we will send, okay, so 16 minus 6x squared equals 0, and we will pass the 6x squared to the other side, plus 6x squared, and we want to divide by 6. So then x squared equals 16 over 6. Let's take this up top, and x squared equals, if we simplify this, it would be better if we said 8 over 3, and if we take the square root, we know that it gives us x equals plus or minus square root of 8 over 3. But we know that we want to get the max area, so we don't want a negative. So now we need to find y, because it asks us for the maximum area that the rectangle can fit on this line. So we simply just plug it in into this. No, into this, sorry. Okay, so y equals 8 minus, parentheses, square root of 8 over 3, and this is squared. So then y equals 8 if we have square root and a square, it cancels out, and we get 8 minus 2/3, which if we convert it to one single fraction, we know that it is 24 minus 2 over, oh wait, this is an 8. Yep, this is an 8. Minus 8 over 3. So y equals 16 over 3. Right? Yep. So it is asking us for the maximum area. So we multiply this by this. So let's go down here, and we know that our x, we got square root of 8 over 3. And for our y, we got 16 over 3. And we just multiply it to get the maximum area. 2 times square root of 8 over 3 times 16 over 3 and that gives us over 3. Is it that? Square root of 8 over 3 times 16 over 3 times 2. Y times 2 gives x. We got x. Maximize it. Got the x. The y. Yeah, it's 2 times that. Then the answer will be 2 times the square root of 8 over 3 times 16 over 3, which is actually 17. 186. So this gives us 17.419. So just 17.4. And we could say that the maximum area of the rectangle is 17.4, and that is